Good day, everyone. We will discuss on parameter sniffing issues with stored procedures in this video. Let's get started. I'm going to use a database called JBSWiki. So I'm going to create two tables for this demo. One is table 1 underscore temp, and that will get its data from table 1. And another table that will be created is table 2 underscore temp, and that will also be getting the data from table 1. So once the tables are created that is required for this demo, what I'll do is I will create two cluster indexes. There is one cluster index on table 1 underscore temp and another one on table 2 underscore temp, and then I'll be creating a non-cluster index on table 1 underscore temp for column 3. Yep. So that is created now. So what I'm going to do is I'm going to create a stored procedure called sp underscore table 1. So this stored procedure is having an parameter column 3 integer, and basically this is selecting column 1, column 2, and column 3 from table 1 underscore temp, and an inner join is performed with table 2 underscore temp, and the join condition is column 1 on each of these tables. A dot column 1 is equal to B dot column 1, and then the predicate is A dot column 3, and then we are getting the parameter of this stored procedure, and that is being provided for the predicate inside the stored procedure. So let me create the stored procedure. So now let's include the execution plan and then execute this query. So I'm going to run both these queries at the same time. So the first execution is going to have the predicate, the parameter value for column 3 as 38, and the next one is going to have the parameter value for the second execution is going to be 500. So let's execute that, and then let's look at the execution plan. So what I'm able to see here is for the first execution where the value was set to 38, what I'm able to see is there is an index seek on table 1 underscore temp. And what I'm able to see is we are estimating close to 55.2 rows, and then we are returning 16 rows. It's a higher estimate. I'm estimating SQL Server is estimating more rows, but end up returning fewer rows. And then on the table 2 underscore temp object, we are able to see a cluster index seek. And if we look at it here, what we are seeing is it is basically estimating close to 55.2 rows, and then it is returning close to 16 rows. Okay, and let's look at the second execution where we have the parameter value set to 500. And if I look at it here, what I'm able to see is for the index seek on table 1 underscore temp, I'm estimating close to 55.2 rows, but I'm returning close to 96,089 rows. And as far as the cluster index seek on table 2 underscore temp, it is I'm estimating close to 55.2 rows, and then returning close to 96,089 rows. So it is very clear right now that the estimate as far as these two things are basically from the cached execution plan. The first time we executed this stored procedure, we gave the parameter value as 38, and the execution plan was basically created for this particular value. And any other execution after the first execution, all are using the same execution plan. So how do we know that? So let's right click on this select statement and then click on properties. And what we are able to see here is if we have so many things here, and I will be interested on this parameter list here. Yeah, if I click on that plus sign here, what I'm able to see here is the parameter compiled value is 38 and the parameter runtime value is 38. That is, the execution plan that is created for this particular stored procedure has a parameter value of 38 when it was compiled for the first time, and this runtime value basically shows us that this is the value which was used for this particular execution. Yep. So now to prove that, let's look at the second one where we have the parameter as 500. So if I look at it here and go to the parameter list, what I'm able to see here is I'm able to see that this execution plan that was compiled for this stored procedure execution basically had, that is the first time the execution plan was created for this particular stored procedure, had a compile value of 38, but this particular execution basically used the execution plan that was created with a value of parameter value of 38, but the runtime value, that is like even though it used this particular stored procedure which this particular execution plan that was created with the parameter value of 38, but the value utilized this time during the actual execution is 500. So this clearly proves that whenever the parameter compiled value and parameter runtime value is different, we will be able to understand, like, it could be a parameter sniffing issue. It could be a bad one where, for example, it can be running properly, or there might be a higher estimate or a lower estimate. So we will have to look at the query, and then depending on that, the execution plan, and depending on what we are seeing, we will be able to take some remedial actions. So moving on, what I'll do now is, like, I will interchange the execution. What I'll do is, like, I will clear the procedure cache. Please understand, this is a lab machine. I will never ever run this command on a production server. Yep, so I've cleared the plan cache, and now what I'm going to do is, like, instead of running this stored procedure with a parameter value of 38, now what I'm going to do is, the first time after clearing the cache, I'm going to run it with a value of 500, and then the second execution will use the value of 38. So let's look at the execution plan. So this time, what we are able to see is, like, we are seeing a completely different execution plan. Previously, we had index seek, and then a cluster index seek, and then a nested loop. But this time, if you see here, we have an index seek on table 1 underscore temp, but we are seeing a cluster index scan. We are not seeing cluster index seek anymore. And also, this time we are going for parallel execution. So this particular icon that you are seeing, the two arrow marks here, or whatever you guys understand, or whatever you are seeing here, that is basically implies like we are going for parallel execution. Okay, so now let's look at the estimates here for table 1 underscore temp. And what I'm seeing is, like, I'm estimating 96,000 rows, and then I'm returning 96,000 rows. And same way for the cluster index scan, I'm estimating close to 15 lakhs. That is the all the rows I'm estimating, and then I'm returning close to 1,10,499. Now, if we move on to the other execution, that is the parameter value of 38, what I'm seeing is, like, SQL Server is estimating 96,089 rows, but it is returning close to 16 rows. Yeah, and also, like, if you look at the cluster index scan, again, like, SQL Server is, like, estimating close to 16 lakh rows, just as like the previous one, but it is returning only 24 rows. And also, like, with just a few number of rows getting returned, I don't think we actually require an hash match. A nested loop should be fine, but since we used an existing execution plan, we had to go with it. So let's look at the information again, the parameter list. If I look at the parameter list, this time what I'm seeing is, like, the compiled value is 500, and the runtime value is also 500, because this is the first execution. So we compiled SQL Server compiled this execution plan for this procedure with a value of 500, and since it was the first time, it is using the same value. And if I look at it here for this particular execution, I will be seeing the difference. So what it basically tells us, like, I compile this, SQL Server compile this stored procedure execution plan with a value of 500, but the runtime value is 38. So this clearly tells us, like, there seems to be a difference in the parameter value, and depending upon in case if there is any estimate issues, and here definitely we have an estimate issue, because we are, like, estimating 96,000 rows, and then returning only 16 rows. It is going to waste huge lot of resource. To be frank, if you see here, there is a memory grant of 14 MB. For example, if used a nested loop, I wouldn't be getting any memory grant at all. So all those things can be resolved, maybe like reduced if we can go for a perfect estimate. And this is happening because of this parameter sniffing issue, wherein you compile the execution plan with a different parameter value, and then the runtime value is different. So what are the solutions for this? The first solution that we can follow is like to add a recompile hint onto that particular statement, which is basically exhibiting the parameter sniffing issue. In our case, we know like this is a select statement, which you basically uses this predicate column 3. So I'm going to add a recompile hint onto that select statement. So let me execute that. And then if I execute this stored procedure now, what will happen is like, let's look at the execution plan. And now what I'm seeing is like I'm getting a different execution plan for different execution. Yeah. So if I look at it here, I'm estimating 55 rows and then I'm returning 16 rows. It's a higher estimate, but seems to be better because I'm not estimating too much or estimating very low. I'm basically estimating 55 rows and then end up returning 16 rows. And for the index cluster index seek, I'm estimating close to 55.2 rows and then I'm returning 16 rows. So it looks to be good. And if I move on to the second one, what I'm seeing is like I'm estimating 96,089 rows and I end up returning 96,089. Seems to be a perfect match. And here as far as the index cluster index scan is concerned, I'm estimating close to 15 lakh 99,000 rows and then I'm returning close to 1,10,000. We can further tune this, maybe like we can add some other indexes and then we can tune it. But as of now, whatever I'm seeing, this seems to be the better option as of now. And is there any other way other than adding a recompile? Yes, we have. What if we use an local variable? So what I'm doing now here is like I'm creating a local variable within the stored procedure. If you see here, declare column 4 integer, and then I'm assigning the value that is assigned to this particular stored procedure. So whatever parameter value comes in, instead of directly giving it to the select statement, what I'm doing is like I'm assigning that to a local variable and then using that local variable into that actual select statement. So let's execute that. And then let's execute the same stored procedure with different parameters. So now if I look at the execution plan, what I'm basically seeing is like I'm not estimating 52 rows anymore. If you see last time, like with no recompile hint, we were estimating close to 52 rows. Yeah, but this time I'm estimating close to 3,516 rows, and then I'm end up returning close to 16 rows, and I don't have a parallel execution. Yeah, it's a serial execution that is going on. And as far as the second execution is concerned, what I'm seeing here is like again, I'm estimating 3,516 rows and then I'm returning close to 96,000 rows. And if I look at the cluster index seek here, I'm again doing the same thing. I'm estimating 3,516 rows and then returning close to 96,000. So using local variable seems to be a little better than not using anything. For example, when we had this plain vanilla select statement without any hints or a local variable, when we are sending the parameter values from the stored procedure directly to the select statement, that was estimating close to 52 rows, and it was like we were returning close to 96,000 rows. That was like the estimates were really bad for that one. For as far as the recompile hint is used, when we use the recompile hint, the estimates were really perfect. The problem with recompile is like every time it recompiles the stored procedure, there will be that extra CPU cycles that will be utilized to recompile the stored procedure. And in case if this particular query is executing several times in a day, or let's consider it is going to be executed several times in a minute or something, there is a high possibility the CPU utilization can go up and also the execution time can slightly go up. So that's something that we need to look at. But as far as the local variables are concerned, doesn't seem like a perfect fit, but what I'm seeing is like it is better than better than the one where we directly send the parameter values of the stored position directly to the select statement. Compared to that, this seems to be better. At least here, what I'm seeing is like even though the estimates are not perfect, it is at least when compared to the previous one seems to be very, very good. That's it for this video. Thanks for watching. Have a great day. Jai Hind.